What questions we come across?
Number 1 through
Shorten it from that. And all phones are up front. Yes? One?
Yeah.
Number 1, square root of 64 is a perfect square, so it just comes out to be 8. What else? Yeah. No. Yeah. Mike. 3. All right. Root 72. So we're going to put this list up real quick. So 1, 4, 9, 16, 25, 36, 49, 64, 81. All right. So root 72. So 72 is going to fall about here. Okay. So I'm pretty sure that 64 is not going to work because I can't go that. 49, let's see, 49 times 2 would be 98, so that's not going to work. 36. What's 36 times 2? 72. Okay, so we recognize this is our perfect square. So what's the square root of 36? 6 root 2. Done. What else could I help you with?
How did you do that?
Well, I have my perfect squares. And I figure out where my number's at. 72 is down here. And I work my way up. I realize 64 is not going to work because I can't go like 1 times 64 is 64, but 2 times 64 is 128, so that's not one there. I can't use 49 because 49 times 2 is 98, 49 times 1, so that's not there. But then I look and say, oh, wait, 36 times 2 happened to be 72, so it broke down. So I'm looking for this to break down.
So how did you get the 6 right up this good?
Because square root of 36
Oh.
is 6, and then this stays behind. So perfect squares come out. You take the square root of it, and they come out. What you got, Mikey? 14. Yeah, buddy. 14. Thank you for asking about this one. This one's a little goofier. So again, let's bring our list of perfect squares up. 25, 36, 49, 64, 81, 100. All right. So there's one of two ways we can kind of look at this problem. Right now, I feel very comfortable that I can go 8 and then root 6 and root 12. Is that okay so far? So I just multiplied outside numbers so far. Follow what I did, Mike? Okay. All right. So now I could choose to multiply 6 and 12 together because they're both underneath, which would give me a bigger number. And I don't know if I would choose to do that or not. So maybe let's see. What is 6? Oh, wait a minute. Is 12 the same thing as 6 times 2? So let's bring that first 6 down. 6 times, that worked. Remember, if I multiply those together, that would have given me 36. So what's the square root of 36? 6. So that comes down here. This 8 comes down here. And I'm left with a root 2. So 8 times 6 is 48. 48 root 2. So, and again, sometimes it might work to multiply the undersides together. Sometimes it might work to realize you could break them apart. So if you break them apart and you start realizing you're looking for pairs of stuff, and you take the pair and you take the square root of a pair, you get the single. Anything else I can help you with? How much? 23? Yeah. So we have, they tell us that A is 6, B is, wait. Take it back. 23. B is 12, C is 13. We want to figure out what A is, okay? So I'm missing one of the legs. The 13 is the longest side. So if I go A squared plus 12 squared equals 13 squared, and then 12 times 12, I believe, is 144. 13 squared is 169. Then subtract 144 from both sides. Those cancel, so I get a squared is equal to 25. And then in order to undo those, I'm going to take the square root of both sides. Square root of 25 is 5. Done. How'd I get what? This is an A. I make my A's like that. My 2's look like that. Anything else? Yeah.
Number 19.
19? Number 19. 3 root 2 times 2 root 32. Okay, so this might be one when I'm looking at it. Right now, I totally know I'm going to get 6 there. So would it make sense to multiply these together in this case? And if so, why? Yeah. So on this one, if you start recognizing your perfect squares, if you multiply 2 and 32 together, you get 64. And 64 is a perfect square. So what's the square root of 64? 8. Now I don't have a radical because I did the operation. I did the square root of 64 to get 8. There was nothing left behind, so then I just multiply 6 and 8 together to get 48. Anything else? 20? Sure. That won't hurt you to see it. Okay, so far on this one, I know I'm going to get a negative 6. Now on this one, if I multiply 3 and 75 together, I get kind of a big number. I don't know if I want that big number or not. So let's do this. Let's bring this 3 down here times. Can I break 75 down to, what's the biggest perfect square that works with 75? 25. So 25 times 3. So now, something to realize. What's the square root of 25? 5. Now, one last thing. We have another perfect square in there. We have this and this. 3 times 3 is 9. What's the square root of 9? So now we don't have a root anymore. So that worked out nicely for us. Let's see. Negative 6 times 5 is negative 30. Negative 30 times 3 is negative 90. Cool. Anything else? Good in the hood? Cool. Will you, my friends, go to page 133? Okay. So we're starting this out. Let's see if we can find a pattern. So if I go root 2 times root 2, I get root 4. What is root 4 equal to? 2. If I go root 8 times root 8, I get root 64. What's root 64 equal to? 8. If I go root 97 times root 97, I get huge. What's the pattern? Yeah, it just comes out to 97. So, friends, when you are when you're multiplying 2 identical roots together, they become a perfect square. So yeah, this was easy to go. 2 times 2 is 4. Square root of 4 is 2. 8 times 8, you get 64. Square root of 64 is 8. But notice I'm not going root 97 times root 97. I just realized, look, take a look. This 2, this 8. Oh, this has to be 97. So what does this next one have to be?
X.
Just X. Yeah, good. All right. All right, let's see. On this one, what does this next one have to be? X squared. Yeah, it's done. Notice when I multiply the 2 identical roots together, and then I take the square root, I get what's originally under the radical sign. Anyone want to take a shot at the third one, or the last one? X to the third. Okay. Huh. All right. So, Let's see. Square root x. Is x a perfect square? No, this is just this. So what's the square root of this? Careful. It's just x. All right, little challenging. Little challenging. So square root x didn't break up. Square root x squared broke up. What? Yeah. All right, my friend, I want to see if you have the pattern. What is x to the third? Okay. Ooh, okay, so hang on. Let's think about this. If I took the square root of x squared, if I take the square root of an even number, and I don't want the radical anymore, I take half of the even number. Half of 2 is 1, so that's x to the first. Take half of 4, get 2. Take half of 6, get 3. Take half of 8, get 4. Okay, so let me put a little note on that. Let's see. When, and maybe put a little note, it looks like you have a little space there. When taking root of even power, so i.e., so friends, what would this have to be? 50. Okay, now let's think about this. I mean, this is kind of ridiculous, but if you see the pattern, notice I took half. Okay, now here's a question. What if I had this? Is 101 an even number? No. But could I take this same problem and do this? X to the 100th times x to the first. So what's the square root of this? X to the 50. And then I have something that's still left behind. X to the first, or could I just put x? Yeah, I mean, I don't have to have this saying x to the first, so I'll make that, well, that's a bad color. I can't see it. I could have it x to the first, or I could have it just like this. Now, a silly thing for me is I'm not going to dock you if you leave something as x to the first. Unfortunately, there are some teachers that might. So just be very cautious. Be cautious. Know the expectation of the teacher. All right, backside, ready? What do you think? What do you think? What do you think? 2x is exactly right. Woo, baby. Good job. So how did I get 2x? Well, I took the square root of 4 to get 2. I took the square root of x squared, so I just took half of x squared to get x to the first, or just x. That's it. Does that make sense? Caleb, make sense? All right. So what do you think I should do with this? Is that even? No, so I'm going to break this into this. Oops. So this breaks up to x root x. What about this? Is this even? If not, what do I have? What do I put under here? X4 and x. Good. What's the square root of x to the fourth? X to the second, and I'm left with root x. Done. This seems... Now, this seems, I think, just by listening to y'all, it seems that you're seeing the pattern. So if the exponent's an even number and you take the square root of it, you just take half of that. If it's an odd number, you go down to the next even number. So if it was x to the 21st, you go x to the 20th x, and then you take half of, once you get the even power out, you take half of the exponent. Okay, so let's kind of keep that in mind. Okay. Let's take care of this 21st. 20 falls in here. So remember, I worked from the bottom up. Let's see if I could do this. 16 times a whole number, give me 20. No. 9 times a whole number, give me 20. This 4 times a whole number, give me 20. 4 times what? 5. Okay. So this is 4 times 5. So the square root of 4 is what? 2. And so far I have this. Now notice I left a space because something's going to happen. But do you feel comfortable with me breaking root 20 to this? Everyone follow the magic? Now, x to the 7th power. 7 is not even. So what should we break x to the 7th down to?
X to the 6th.
X to the 6th and 1. Right. Like that. Good. All right. So what is the square root of x to the 6th? X to the 3rd. And then I'm left with an x underneath still. That's my answer. So let's just pause there for a minute. Do you follow what we did? I tried to change some colors. I referred back to the perfect squares. Huh. Look at that. You feel good? Can I move on? All right. So let's write our perfect squares up because I can't remember them. So 4, 9, 16, 25, 36. Can I stop there? Where does 36 fall? That's 36. So what's the square root of 36? 6. All right. What's the square root of this? X. What do I have to do with this? So I had this. Do you agree? So what's the square root of this? Y. Do I have a y left behind? Now, I've heard all kinds of terminology with this. I've heard terminology. This is a jailbreak. Or let's make it more positive. So your friend shows up to your window on a Friday night. Come on out. Let's go have fun. Let's go. But your buddies in the other room doesn't get to come out because they get left behind. Your buddy didn't go there. So that's a bad analogy. Sorry. I should think things through before I speak. It just happens. All right. Do you feel comfortable with that? Okay. Let's take a look at this one. So I'm going to write my perfect square. So I get 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. Okay. So let's think about this. I don't really have 200 on my list, but what can I break 200 down that'd be a little nicer? 100 times 2. And then, is it okay if I leave that as a squared? What should I do to this one? B squared times? B squared times? B. Can I leave this one alone? Yeah, it's an even number. All right, let's do our square root. What's the square root of 100? 10. What's the square root of a squared? A. What's the square root of b squared? What's the square root of c to the 4th? C to the 2nd. Is there items left behind? A b. Anything else? A 2. So 2b. There's my answer. Seem okay? I have one last one. Agree?
Yeah.
What's that?
1 sec.
1 sec? Okay.
I got it. The one on the bottom, that's it.
Yeah, the one that's boxed in. So this is just kind of my work.
I write that down on sheet.
Cool. No, and I write down so it helps you. You all good, Fred? Who's Fred? I don't know. All right. Ooh, okay. Let's see. I'm going to take my time on this. I'm going to put it all underneath one radical. So let's do this. Let's talk about the 18 and the 10. I guess I could multiply them together to get 180, but my perfect squares only go to 144 that I have to go up to. So let's see if we can break those down a little bit differently. Well, actually, let's do this. Let's list our perfect squares. 149, 16, 25, 36, 49, 64, 81, 100. I think we've gone far enough. Let's take a look at 18. So 18 is like here. So let's think about this. Can I break 18 down to be the multiple of any of those? 9 and 2, right? So 18 breaks down to 9 and 2. Okay. What about 10? Does 10 work? I mean, 10 falls like right here, right? Let's see. So 9 times the number would give me 10. No. 4 times the number would give me 10. No. I wonder if I could. Can I break 10 down? To 2 and 5, right? All right. So hang on. What's the square root of 9? 3. So 3's outside. But is there another perfect square sitting amongst our numbers right this second? No, don't worry about the letters, just the numbers. Yeah, this makes a perfect square if I multiply it together. Agree? So what's the square root of 2, 2? AKA the square root of 4? 2. Okay. So far I know that. Now I'm not done, and I'm going to bring kind of a radical over here a little bit, because I think stuff might go in place. All right, so now let's look at the x's. I have x to the third and x to the fifth. Okay? So remember, those are exponents. 3 and 5 are exponents, right? Exponents are like bunnies. And this joke will finish later. Exponents are like bunnies. When they're all next to each other, you count them up. You add them up. So how many x's do I have underneath? 8. Now, is x to the 8th an even number? Yeah, so hey.
How you doing?
Doing well. Gotcha. Thanks.
Thank you.
All right. What's the square root of x to the 8th? Is that? Yeah, x to the 4th. Okay, let me stop there. Does this make sense how that worked? It came out of the radical. I took half of it. Okay, now, how many y's do I have underneath? 3. So should I keep them separate? If I keep them as y to the 3rd, I can't take the square root of y to the 3rd. I want an even number. So I think on the y's, I'm actually going to keep them just like this. Because what's the square root of this? How much? Y? What? Excuse me? The blessing came too quickly. It's gone.
Was your nose playing games with you?
It is. All right, my friends, I have 3, 2, x to the 4th, and y that all came outside. We'll have to clean that up in a minute. What do I have underneath that didn't come out? What didn't come out? Y. Anything else? 5. So 5y. So the 5y's got stuck. So now let's clean it up. The only math I have to do here is I got 6, x to the 4th, y, root 5y. And it's done. My friends, if you take your time with these, yeah, you might make mistakes. But the hard thing is when you start trying to do it in your head going, oh, it's this. And then you forget to put something back underneath. Okay? All right. My friends, I feel think you can take care of page 135, 136. I think you can do them all. It's only like 17 problems. Try them. Friends, if you can keep trying, I mean, some of you are doing, most of you are doing really, really good job. You're on top of it. You're at least trying it, so your thought process is working, and then we get the corrections made where we need. So keep it up. Yeah. Wait, what? No, no.